Hello everyone. In this video today we're going to review problems for the elementary algebra midterm. We're going to go over the problems that are highlighted, which is majority of them, so I expect this video to be a little longer. We'll start with number 1, and you're asked to simplify the expression by using the distributive property. The distributive property is simply you taking the term that is outside parentheses and distributing it. You're multiplying it by each of the terms inside parentheses. So these arrows represent the multiplication that's going to happen here. Now, when we look at our solution or begin to write our simplification, we have negative 5 times 6n, and that gives us negative 30n. Now we have a negative 5 outside and a negative 5 inside. A negative times a negative will make that negative 5 times negative 5, or positive 25. You see this plus 3n at the end. We'll just attach that term to the end. And now we're going to combine any like terms. We have negative 30n plus 3n. Since both of those terms have n's at the end, we can combine them, and negative 30n plus 3n will give us negative 27n plus 25. And that 25, we just brought that down from in the middle. And that's our solution for the first problem. All right, now let's look at example number 2. Now in example number 2, you see some terms in the numerator, some terms in the denominator. You want to combine those terms. We first simplify the terms at the top in our numerator, and then simplify the terms in our denominator. The last step is we're going to divide the two numbers we get. So using our order of operations, we should perform terms or operations that are in grouping symbols first. So the 8 minus 4, we would perform that step first. 8 minus 4 gives us 4. And then we'll carry over the plus 1. So that can be simplified a little bit further. 4 plus 1 gives us 5 in the numerator. We'll do the same steps in the denominator. Now we have 10 plus 3 times 4. Using our order of operations, we know that we have to multiply first. So we have to multiply 3 times 4. That gives us 12. And we'll carry over the 10 that's in front and the plus sign behind the 10. So we can simplify this a little bit further in the denominator. 10 plus 12 gives us 22. Now you want to check and see if you can simplify that fraction. You're really asking yourself, is there anything you can divide into 5 and 22 to reduce the fraction? And you can't, so you leave it as 5 over 22. Now look at number 4. You're evaluating this expression when x is negative 24 and y is 576. So everywhere you see the letter x, you're going to replace negative 24. And everywhere you see the letter y, you're going to replace 576. So let's do that work. Now when we substitute for x, we get negative 24. I'm going to put it in parentheses. Negative 24 raised to the second power minus y, but instead of y, we're going to add 576. And then we simplify here. So if we simplify negative 24 squared, remember what you're being asked to do here. You're really squaring that term. So that means negative 24 times negative 24. And we know that a negative times a negative will wind up being positive. So you just want to remember those rules about multiplying negatives. Now you guys can use calculators, so you just want to punch in negative 24 times negative 24, and you should get positive 576. And then look, we're going to carry down the minus sign and the 576 from above. And what do we get here when we subtract? Just 0. So this is our solution for number 4. Now look at number 5. We're going to solve this equation and check our solution. So when we solve this equation, let me rewrite it over here. Make some separation. So we got negative 12 equals x plus 2. Your goal is to get x by itself. So I'm going to circle that x. We want x by itself. In order to solve for x, we got to get rid of this 2. And remember, when I say get rid of it, that means shift it to the opposite side of the equal sign. Your equal sign is dividing this equation into a left and a right side. We want x by itself on the right side of the equation. Now to shift that 2 to the left side, we have to perform the opposite operation. The opposite of adding 2 is to subtract 2. So we're subtracting 2 from both sides of the equation, the right side and the left side. Now 2 minus 2 on the right, that cancels, leaving x. Bring down your equal sign, and negative 12 minus 2 gives us our answer, which is negative 14. So that's number 5. Let's keep going. Looking at number 7, we're solving another equation, so I'll rewrite the equation. 9y minus 5 equals 7y plus 3. Now this time we're combining 2 sets of like terms. And we show arrows here. We're combining 9y and 7y. And to do that, it's a positive 7y on the right, so we're going to subtract 7y from both sides of the equation. So minus 7y on the right, minus 7y on the left. The 7y's will cancel on the right side, leaving 3. We'll bring down the equal sign, bring down the negative 5 that's in front of the equal sign, and then subtract. 9y minus 7y gives us 2y. Now we'll continue to solve here. We aren't done until we get y by itself. And you always remove the term that's not attached to the variable first. So we're going to add the 5 to move 5 to the right side of the equation. We're adding 5 on the right and the left side. So negative 5 plus 5 will cancel on the left, leaving 2y. So we carry down our 2y. Carry down the equal sign. And then we're adding on the right side. 3 plus 5 gives us 8. The last step is to divide both sides by 2. And we'll get y equals 4. Now, if we wanted to check these solutions for these equations, what we would do is go back and substitute our answer for the variable. So if we're saying y is equal to 4, everywhere y is, we substitute 4. That would be 9 times 4, which gives us 36. 36 minus 5 on the left side, and we're just checking to see if that would be equivalent. I'll put a question mark there. Is that equivalent to when I plug in 4 for y on the right side of the equation? So that would be 7 times 4 plus 3, or 28 plus 3. And we're just checking to see if both of these sides are equivalent, and they are. So that lets us know that we have the right solution. Okay, we'll get 31 for both of these. All right, let's move on. So number 10, we're asked to find the perimeter of this geometric figure. So we have a 5-sided figure, that would be a pentagon, and we have expressions to represent the length of each side of the pentagon. So we have x, 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 3 sides with a length of x, and then 2 sides with a length of 2x. Remember, the perimeter is just us adding all of the sides. So we're going to use the information given to us in the question to find the value of x and 2x. Now, we're told in our description here that the perimeter of the pentagon is 70. What that means is when I add all the sides together, I should get 70. So that's how we're going to set up our equation. Just add each side of the pentagon. We got x plus x, 3 x's, plus 2x and 2x. All of that is equal to 70. Now I want to combine like terms over here on the left side. All of these terms are x terms, so I can just combine them. 1 plus 1 plus 1, that's 3x, plus 2 would be 5x, plus 2 more would be 7x in all. And all that is equal to the right side of the equation, which is 70. And then we just solve this equation. So we'll divide both sides of the equation by 7. And we'll get x equals 10. So down here in your solution, you'll get x equals 10. But we don't stop because you're still asked to find 2x. We want to know what the longer side is. So now that we know the value of x, we can substitute it. 2 times 10 or 20. And that will be your solution for number 10. All right, let's look at number 12. The birthday celebration meal is $54.20, but that includes tax and not the tip. So we want to know the total cost if we add a 15% tip to this meal. All right, so to get the total cost, we're going to add two things together. We're going to add the price of the meal, and let's write that up here. Total cost is equal to the price of the meal plus the tip that we decide to leave, which in this case will be 15%. Now we already know what the price of the meal is. It's given to us. It's $54.20. We just need to find the tip, right? So we need to find this value. And to get the tip, we're going to multiply this 15% as a decimal. Remember to change this to a decimal. So it'll be 0.15 as a decimal. You either divide by 100 or you remember to move your decimal 2 places to the left. And that's how we convert a percent to a decimal. We shift the decimal point 2 places to the left, or you can divide by 100. So I'm going to take that decimal, the 0.15, and I'm going to multiply it by the price of the meal. So times, let me use a different symbol. So that's 0.15 times the $54.20, the price of the meal. And this would give us the tax that we got to pay. So in your calculators, you simply just punch in the 0.15 times 54.20, and you'll get $8.13. You get 8.13 in your calculator. That represents, this number 8.13 represents the amount that you want to pay for a tip. So we're going to add that $8.13 to the $54 in order to get our total cost. This is the TC. So adding the 8.13 to the total cost of the meal, which was, or not the total cost, but to the cost of the meal, which was $54.20. And that'll give us $62.33. And that's our answer. This is how much you'll pay out the door. Now let's look at number 13. That was number 12, $62.33. Now let's look at number 13. We're finding the original price of a pair of shoes if the sale price is $10 after a 75% discount. All right, so let's rewrite this scenario here. Now, first of all, to find the original price, let's just use OP. To find the original price, when we know we had a discount, right, we'll take the sale price since we know we got a sale price of $10, but in order to get that sale price of $10, what you had to do was take the original price, we're using OP to represent the original price, and you had to subtract the discount. So our sale price we already know is 10. The original price we do not know. So since we don't know that, I'm just going to call it X minus the discount. Now, how do we get our discount? Similarly to how we changed our 15% to a decimal, we have to do the same thing with 75%. Let's change the 75% to a decimal. It'll be 0.75. And we have to take that discount and multiply it times the original price. But remember, we don't know what that is. So we're still using X. It'll be minus 0.75 times X, since we don't know that original price. Now over here on the right side, what you see is two like terms. That's the same as being 1x minus 0.75x. And you can just punch that into your calculator. Do 1 minus 0.75, and what you'll get is 0.25x equals, bring down the 10 on the left side of the equal sign, and then we just want to solve this equation. We get x by itself, we would divide both sides by 0.25. 0.25 will cancel on the right side of the equation. On the left, you just punch in the values that you see. You have 10, and you want to divide 10 by 0.25. And that'll give you 40. 40 is equal to x. But what does x represent? The original price. And that's what you were asked to find. So that's your answer. All right, that's your answer for number 13. And I'll need to make some space here for number 14. We have D equals 1/4 FK, and we're solving this for F. If we're being asked to solve for F, what that means is we need to get F by itself. Okay, so if I rewrite this here on the side, we have D equals 1/4 FK. We want K by it, or we want F by itself. So in order to get F by itself, let me circle our letter. We want F by itself. We need to get rid of the K and the 1/4. Now, to get rid of the 1/4, we would divide by 1/4, but dividing by a fraction is the same thing as multiplying by the reciprocal. So really what we need to do is flip this fraction, take the reciprocal, right? And if we flip this fraction, take the reciprocal, the denominator moves to the numerator, and the numerator moves to the denominator. That would be 4/1. And you're going to multiply both sides by that reciprocal. I'm putting 4/1 in parentheses here. On the right side of the equation, I have to put 4/1 in parentheses on the left side of the equation too. So we divide both sides of the equation by 4/1. On the right side, when we divide 4/1, and we're multiplying 4/1 times 1/4, the 4's and the 1 will cancel out. So those two terms, the fraction and its reciprocal, will cancel, leaving FK on the right side of the equation equals. On the left side, you have 4/1 times D. That's just 4D. Now we aren't done yet because we don't have F by itself. The last step is to get rid of the K. We're going to divide both sides, the right and the left sides, by K. The K's will cancel on the right. So now we have F equals, and this is your answer, 4 times D in the numerator all of that divided by k. All right, let's look at the next problem. We're looking at number 15. And we're asked to solve this inequality and then graph the solution set and write it in interval notation. So we'll put our interval notation, we're going to match our graph. Now, first of all, when we get ready to solve this inequality, we really use the same steps that we use to solve equations. But there's one caveat when it comes to working with inequalities, and that's if you multiply or divide by a negative number. If you notice here, to solve this inequality, we have to divide both sides of the inequality by -4, which means we have to reverse this symbol. Because we're dividing by a negative number, we have to reverse this symbol, and it's switched from less than or equal to greater than or equal to. Our solution will be x greater than or equal to, and 16 divided by -4 is -4. So this is our solution. We're going to match it with its graph. Look what direction this arrow is pointing. It's pointing to the right. And we know we're looking for a graph that's shaded to the right. We have two options, B or D. Now we need to determine whether we should use the bracket or the parentheses. Remember, you use the brackets whenever your symbol is less than or equal to or greater than or equal to. And then you use parentheses when you have less than or greater than by themselves. In our case, we have greater than or equal to, so we should be using the bracket. All right, so that leaves here answer B as the correct graph. We got a bracket at -4 and we're shading to the right. Now, how do we write this in interval notation? We have a bracket at -4. We put bracket -4, comma, and we're shading in the direction of positive infinity. So positive infinity, and remember, you always have parentheses around infinity. So interval notation, we got bracket -4, comma, infinity, parentheses. All right, we're moving on. Let's look at number 18. We're solving another inequality. Let's rewrite it here. 7x minus 6 less than or equal to 9x minus 4x. We solve this inequality by combining our like terms. We're going to first subtract 9x from both sides. The 9x will cancel on the right. We'll bring down our inequality symbol. Actually, we have another x term that we can combine, huh? The 9x we're subtracting, that left us with -4x. We have a -6. And then 7x minus 9x will give us -2x. Now what you notice is there's another x term. So we really could have combined the x terms from the beginning, but since I didn't do that, we added an extra step that was unnecessary. So we're going to add 4x to both sides of the inequality. And -4x plus 4x gives us 0 on the right side of the inequality. Bring down your inequality symbol, the -6 that's in front of the symbol. And then -2x plus 4x, that just gives us a +2x. So we aren't quite done yet until we get x by itself. So we're going to add 6 to both sides of the inequality. And the 6 and -6 will cancel on the left, leaving 2x. Less than or equal to, we still have our same inequality symbol, 0 plus 6 or 6. And then divide both sides of the inequality by 2. So x is less than or equal to 3. This is our solution, right? We're going to match it with the correct graph. Now the direction our arrow is pointing this time is less than, it's pointing to the left. So we're looking for a graph that's shaded to the left and one that has brackets. So look at our symbol, it's less than or equal to. So we're looking for a bracket at 3 and an arrow that's shaded, or a graph that's shaded to the left of that bracket. So positive 3 with a bracket here, it will be letter A. Now, interval notation, we have our negative infinity first. So negative infinity, it looks more like an 8, but negative infinity with parentheses, comma, and then positive 3 with a bracket. That will be our interval notation. So negative infinity, always use parentheses for infinity, comma 3, and then we have a bracket at 3. Let's look at number 20. By decreasing each dimension, so we decreased one shape from 50 square feet to 14 square feet, the area of the rectangle decreased from 50 to 14, and we want to find the percent decrease. Now, to find the percent decrease, we would use the following steps. So let me just use the percent symbol here, percent decrease. To get our percent decrease, what we do is we take the difference in area, since we're talking about area for this problem, will be equal to the difference over the original amount, whatever you started with, times 100. Now, when you divide the difference by the original, you'll wind up with a decimal, and you have to change that decimal to a percent. So that's why you multiply it by 100. So what do I mean by difference? What was the change? To go from 50 to 14, how far down did we go? So you got to subtract. That's why we take the difference, or what we mean by difference. So 50 minus 14 will give us the difference. You always take the largest number, the largest of the two, and you subtract the smaller one. So 50 minus the 14 will give us 36. So in the numerator, where the difference is, we have 36. Now we're dividing that number by the original amount. Our original amount is what we start with. In this case, it's 50. So you take your 36, divide that by 50 in order to get the decimal. And when you divide 36 by 50, you get 0.72 or 0.72. The next step is to multiply by 100. So we'll take the 0.72, multiply it times 100, or you can move the decimal 2 places to the right. You'll get 72%. That's how much of a decrease we have in areas. So 72% decrease. All right, let's look at number 21. We're going to simplify this expression, and we want to make sure our result only has positive exponents. All right, and let's look and see what we have here. We got A's and B's, letters A's and B's. We have 6 in front of our term. We want to combine all those terms that are alike. So the 6 and the 6, I'm just going to write them separately. We got 6 over 6 to the negative first power. And then our A terms, we have A in the numerator divided by A to the negative fourth power. Our B terms, we have B to the negative fifth power in the numerator and B to the positive fifth power in the denominator. Now for each of these terms, our quotient rule, when we divide terms that have the same base, we keep the base. So this base would say 6, this base would say A, this base would say B, and then we subtract the powers. So I have a 6 with no power. There is an invisible 1 there. It can't be 0, because remember, anything to the power of 0 is 1. So that's 6 to the first power divided by 6 to the negative first power. It's top power minus bottom power. And that would give us 1 minus, I'm going to put this in parentheses so we can see what happens here. It's 1 minus negative 1. And remember, 1 minus negative, whenever you see these two negatives side by side, that actually becomes addition. And that's 1 plus 1, or 6 to the second power. Here, for the a terms, I have a to the first power in the numerator. That's 1 minus negative 4. And again, we have negatives side by side. That becomes 1 plus 4, or a to the fifth power. In our b terms, we have negative 5 in the numerator, minus 5 in the denominator. And negative 5 minus 5 will be b to the negative 10th power. Now we combine all this stuff together. We got 6 to the second power, that's 36. A to the fifth power. And then our b to the negative 10th, we need to make sure that that's positive. And remember, to make the exponents positive, you move it down to the denominator. So that becomes b to the positive 10th power, but in the denominator. That's our final answer. When we rewrite it, we got 36 a to the fifth divided by b to the 10th power. Now let's look at number 22. We're writing this number in scientific notation. Now remember, if you don't see a decimal point, the decimal point begins at the end of the number. And your goal is to move that decimal point to a spot where the digit that's in front of it is 1 through 9. Okay, it can't be smaller than 1, and it can't be larger than 9. So I will move this decimal point 1, 2, 3, 4, 5, 6 spaces to the left. That becomes 1.8 times 10, and then your power will come from the number of spaces that you had to move to the left. In this case, we had to move 6 spaces to the left. That will be our answer. 1.8 times 10 to the 6th power. All right, let's look at number 23. We're finding the degree of the polynomial, and we're determining whether it's a monomial, binomial, trinomial, or none. Remember, monomial means we have one term. Binomial means we have 2 terms, and a trinomial means you have 3 terms. If your expression has more than 3 terms, then you would say none of these. When it comes to the degree, remember, the degree is the highest power. When we're looking for the exponent, the highest number, highest power. So what are our powers here for each of these terms? We have x to the second power, that's 2. X to the fifth power, that's 5. X to the third power. So our highest power is going to be 5. That's our degree. So what is the degree of this polynomial? It's 5. Fifth degree. And how many terms do we have? We have 1, 2, 3 terms. And we would call it a trinomial. And that's letter C. That's our answer for number 23. All right, let's look at number 24, 25, and 26. For 24, we're adding the 2 terms in parentheses together. So we're adding everything in the first set of parentheses to everything in the second set of parentheses. Now I'm showing this arrow because it really will come into play more so in number 25 because your signs will be impacted. But for 24, not so much. We have negative 8y squared minus 6y plus 9y squared. So we're looking at the second set of parentheses now. Plus 2y minus 9. We want to combine terms that are alike. So we have negative 8y squared and positive 9y squared that we can combine. Negative 8y squared plus 9y squared is just 1y squared. We don't have to put the 1 in front of the y. So we're done with the y squared terms. Next, we have negative 6y plus 2y. That will give us negative 4y. And then minus 9 on the end, since there aren't any other constants. That will be our solution. Now let's look at 25. We got 7x minus 8x, and then minus minus, that becomes positive 5. We want to combine like terms. We just have these two like terms. 7x minus 8x will give us negative x. Negative 1x, but we don't have to write the 1. And then we'll carry down the 5. That's our answer for number 25. Now let's look at number 26. We're multiplying here. We're really distributing the 5x times all three of the terms in parentheses. So we have 5x times 2x squared. That gives us 10x to the third power, right? Because we have 1x and then we add the 2. When we multiply, we add the powers. Minus 5x times negative 5x. That's negative 25x to the second power. We have the 1 outside, the 1 inside. We add them together. And then 5x plus 3. That gives us a positive 15x. Now, our solution, our directions say to simplify our answer. And we've already combined all of our like terms together. There aren't any other terms that can be combined because each of these have different powers. So we leave it as such. 10x cubed minus 25x squared plus 15x. Now 28 is actually very similar to 26, except you see how you have that parentheses and you have all of the terms in parentheses raised to the second power. That means you got to rewrite this as two sets of parentheses. That means I'm duplicating the 8y minus 8 times itself. I'm multiplying it by itself 2 times. I'll write another 8y minus 8, and then I'm going to multiply the terms together. So everything in the first set of parentheses, I'm multiplying by each of the terms in the second set. So these arrows show the 4 multiples that have to happen. So 8y times 8y gives us 64y to the second power. 8y times the minus 8 gives us negative 64y. Negative 8y times 8y, these terms in the center, gives us another 64y. So then lastly, negative 8 times negative 8 will give us a positive 64. Now we're combining the terms that are alike, and we notice that it's really just these two middle terms that are alike, the 64s. We got two negative 64s. So a negative 64 minus 64 will give us negative 128y. We'll carry down the plus 64 on the end and the 64y squared in front. We get our 4 here, and that will be our answer. 64y squared plus 128 plus 64. All right, let's keep going. Number 30, we're dividing here. So I really want you to see these division problems as being separate, similar to how we, now let me erase this line here. So similar to how when we distribute and multiply a term, you're also going to distribute with your division, okay? So what do I mean by that? this 10x to the 7th power, we're dividing it by both of the terms on top. So that's negative 35x to the 6th power divided by 10x to the 7th. And we're going to divide the 10x to the 7th by 40x to the 7th. So 40x to the 7th is also divided by 10x to the 7th. All right, so you want to look at it as two sets of division. Now, looking at the first two terms, we have negative 35 and 10, just looking at the integers. Now, 10 can't be divided evenly into 35, but we can simplify that a little bit. We can simplify it by dividing both numbers by 5. So I'm just showing that we're dividing negative 35 by 5. That gives us negative 7. And 10 divided by 5 gives us 2 in the denominator. Now, with regards to the x terms, remember when you have terms that have the same base, x, you're going to subtract their powers. So that will be x, and our powers, 6 minus 7. It's always top power minus bottom power. Now with our 40 and our 10, 40 divided by 10, this time it simplifies, right? Because 10 can go into 40 4 times. And our powers, we have x, same base, 7 minus 7. So that'll actually give us a 0, right? So let's simplify this a little bit. I'm going to write it to the right. Negative 7 halves. Negative 7 halves. Let's erase that and put a 2. So negative 7 halves. And our variable, remember when we subtracted here, we subtracted 6 minus 7. Negative 7 halves. And 6 minus 7 gives us x to the negative first power. Now with the 40 over 10, we got 4, and that's positive, so positive 4. And x to the power of 7 minus 7, or 0. So we can simplify this even further because x to the negative first power, we don't want negative power. So we know we should rewrite this expression, bringing x down to the denominator so we can make the power positive. So that'll become negative 7 over 2x plus 4 times x to the power of 0. But what is x to the power of 0? That's just 1. All right, and 1 times 4 is just 4. So this will be our solution. 7 over 2x plus 4. Now let's look at number 31. We're asked to factor out the GCF. Now we want the greatest common factor. We want to find the biggest number that we can divide into 14, 4, and 16. The biggest number that we can divide into 14, 4, and 16 is going to be 2. Right? 2 can be divided into each of those terms. Now, what do I multiply 2 by to get 14x to the 7? It will be 7x. Let me give us a little bit of space here. And let's go back to this. All right, so 2 can be divided evenly into 14x and 16, but there's also another term that each of these share, and that's x. Since each of these terms have at least one x, we can also factor out one of the x's. So not only 2 in my factor, I'm factoring x from each term. So what do I multiply 2x by to get 14x to the 7th? That will be 7x to the 6th. Why? Because we factored out one of the x terms, leaving 6. Minus, what do I multiply 2x by to get? 4x squared, that would be 2x. And then plus, when we multiply 2x by to get 16x, that's just 8. All right, and that will be our solution. Now let's look at number 32. We're going to factor by grouping. Now remember, when we're factoring by grouping, what we want to attempt to do is group together the first two terms and the last two terms. And then we find the GCF between both of those terms, the greatest common factor. So is there a factor between 3x to the fourth and minus 2x squared that we can factor out? Yes, because they both have x terms. The greatest number of x terms that I can factor 4 from 3x squared. I can factor 2 from 2x squared. So I can factor at least 2 of the x terms from both 3x to the fourth and minus 2x squared. So when I factor x squared from 3x to the fourth, I ask myself, hey, what do I multiply x squared by to get 3x to the fourth? And it's 3x squared minus, what do I multiply x squared by to get 2x squared? It will just be 2. So I factored out x squared. I got 3x squared minus 2 in parentheses. We want to find our GCF, our greatest common factor, between the next group. So what can I factor from 15x squared and 10? We know we can factor 5, so let's try that. What do I multiply 5 by to get 15x squared? It's 3x squared. That looks promising because we have 3x squared in the first set of parentheses. Now what do I multiply 5 by to get the 10? The minus 10, it will be minus 2. All right, so we know we factored it correctly once we see a shared factor in parentheses. So our solution would be 3x squared, that's one of our factors, minus 2. 3x squared minus 2. And then our second factors would come from the terms that are on the outside. So x squared plus 5. We have a positive 5. And that's our solution. 3x squared minus 2 and x squared plus 5. All right, let's look at number 33. We have the trinomial x squared, I'm going to recopy it here, minus 4x minus 45. Now we're factoring, but we need to figure out the right combination. So we're trying to find two numbers that multiply together to give us negative 45. So factors, two numbers that multiply together to give us negative 45, but when we add them, we get negative 4. So factors of negative 45 will be 9 and 5, 45 and 1. But really this 9 and 5 combination looks good because I can change one of these to a negative, right? Negative 9. And when I add negative 9 plus 5, I'm checking to see if it also gives me a sum of negative 4, and it does. Because negative 9 plus 5 gives us negative 4, our middle term, these are the two factors we want to use. So we should have a minus 9 and a positive 5 as our last term in both sets of parentheses. Now the first term will come from factors of x squared, and there are only two terms that multiply together to give us x squared, that's x and x. So these would be our factors, x minus 9 and x plus 5. All right, let's look at number 37. Now how do we factor a binomial? Now we notice that the term binomial, that really refers to only two terms. Whenever you see a minus in between two terms that are perfect squares, remember a perfect square is a number you get when you multiply another number by itself. So 5 squared gives us 25. That's why 25 is a perfect square. 9 times 9 gives us 81. That's why 81 is a perfect square. So whenever you have a minus in between two perfect square terms, we would factor it using two sets of parentheses. One should be a plus, one should be a minus, and in front would be those numbers you multiply together to get 25x squared. Remember, we want that perfect square, so it will be 5 and 5. And then how do we get x squared? X and x. 5 times 5 gives us 25. X times x gives us x squared. All right, now our 81, what two numbers do we multiply together to get 81? It's 9 and 9. And this will be your answer. 5x plus 9 and 5x minus 9. Now we're going to solve this equation. Now in order to solve these equations that are already factored, like 38, you're just going to set each of these factors equal to 0 and solve. So x plus 5 equals 0, and x plus 18 equals 0. I'm going to solve both equations to get our solutions. To solve the first equation, we're going to subtract 5 from both sides of the equation. The 5's will cancel, and x is equal to negative 5, or, all right, so x is equal to negative 5, or, let's solve the second equation. We're going to subtract 18 from both sides of the equation. X equals negative 18. So here are your two solutions, negative 18 or negative 5. All right, let's look at number 39. So 39, you see how it's not factored already, so we got to factor first. And before we can factor, we need to make sure that the equation is set equal to 0. So that 24 needs to be moved to the right side or the left side of the equation. We want to subtract 24 from both sides to do that. The 24s will cancel on the right side, leaving 0. That's what we want. And on the left side, we have x squared minus 2x, and then minus the 24. We're going to factor. So we want to open our parentheses, and we got to find two factors that multiply together to give us negative 24, but when we add them, we get negative 2. And we're looking for factors of negative 24. 6 times 4 would work, right? But we have to decide which of these terms should be negative. Because we want a negative 2, then we need the bigger number to be negative. We can check that. Negative 6 plus 4, does that give us negative 2? And it does. So we know these are the correct factors. So we have a minus 6 and a positive 4. Our x squared will be factored as x and x. Now that we've factored, we want to solve the equation, so we're going to set both of those factors equal to 0. So we have x minus 6 equals 0, or x plus 4 equals 0. I'm going to solve both equations. I'm going to add 6 to both sides of the first equation. And we'll get x equals 6, or let's subtract the 4 from the second equation. X equals negative 4. So those are your two possible solutions, positive 6 or negative 4. And that concludes our review for the midterm. Good luck on the exam.